So, useful little trick to do with units. As I've written here, a lot of the time you can use the units to work out the formula, or maybe the formula to work out the units. We start off with speed is equal to distance over time, and you're trying to remember what the unit of the unit of speed is. Let's say the distance is 10 meters, the time is 2 seconds. The speed is equal to 10 meters divided by 2 seconds. And you can take this m and s, like we do in algebra, and we end up with 5m divided by s. So this little slash, which we read as per meters per second, it just means divide. So let's take another example the other way around this time. The unit for momentum is a bit strange. It's not kilogram per meters per second, it's kilograms meters per second. Sometimes what you'll get is a dot in between the units, but you don't have to do that. It just means kilograms meters per second, therefore it's kilograms times meters per second. Well, the unit for kilogram is the unit for mass, and meter per second is the unit for velocity. It's also the unit for speed, but so it doesn't always work, but because momentum is mass times velocity, not mass times speed. But that's just because momentum is a vector and velocity is a vector, whereas speed is not a vector. But anyway, mostly it's mass times velocity. Another time it might not work is when you have something like this. Work done is force times distance, and that gives you 15, but it's not Newton, although I think technically in some situations you can refer to it as a Newton meter, but you shouldn't really do that, and it's the unit for work done is actually joules. So there are times when it doesn't work, but a lot of the time it does work, so it's worth noting that. So this little slash just means per. Okay, we'll do one more example, which is acceleration, because this is a unit that people often get confused by. The unit for acceleration, let's say acceleration is 5, is meters per second squared. So this weird idea of squaring a second confuses a lot of people. But if we think about what acceleration is, it's when velocity is changing, and it's how quickly it's changing. So it's the change in velocity divided by the change in time, or the amount of time, or whatever, the change in time. So let's say that, take our previous question, we accelerated from 0. Well, actually, I'll do a different one. We'll say that it's going from 2 meters per second to 5 meters per second. So the change in velocity is going to be 5 meters per second minus 2 meters per second. And let's say it did that in maybe 10 seconds. So 10 seconds. So that's going to be equal to, we use the same sort of thing as like we did before, 5 minus 2, and we can take m slash s as like a common factor. Or we can think about it in the same way as maths, just collecting the like terms on the top. So 3 m over s, and then divided by 10s. So again, we'll do, how would we do that again in algebra? Well, we've got 3 over 10, which is 0.3 m over s, and we've got it over s again. Well, that's the same as saying 0.3 m over s multiplied by 1 over s, which is 0.3 m over s squared, and that's why the unit is meters per second squared. So yeah, you can actually get away with saying meters per second, but you'll more commonly see meters per second squared. So yeah, that's how you can use formulae and units interchangeably to remind yourself of each one.